right, so in this spell work here, I have some equations, so 3 equations, and you have to match it up to the graph that it resembles it the closest. So in this case here, take a look at maybe like the slopes, the y-intercept. That might really help you in detecting which one would be the best fit. So like this one here, I notice the slope is 2, so that tells me a positive slope, so something that's going like upwards, and a y-intercept of 3. So y-intercept of 3, it looks like it has to be one of these 3, and then a positive slope, that would have to be this one. This one's kind of shooting upwards as it continues on. So I think B here is the correct answer, since it hits at about 3 and then looks like the line is increasing. Whereas for number 2, this says a negative 2x instead. So it still has the same intercept at 3, and then this time it's decreasing. So I think C resembles the closest to that. And then for number 3, y equals 3. Well, when y equals a number, that means it needs to hit y equals 3 on the chart, which would have to be this one here, and it needs to be a horizontal line. So this would be a y equals 3 type of equation, so this has to be A. Whereas this one that's to the side here, notice how it hits the x-axis, and this could have been, let's say it hits it at 3, so this could be x equals 3 as its equation that describes this particular line. So when you have a vertical line, that's when you have x equals some number. All right. So now that we've kind of, played with some graphs and matched up with its correct equation, today I want us to talk about writing the line equation if you're given some conditions. So let me show you 2 forms that can help you write the equation of a line. So in this case, we are more familiar with y equals mx plus b because that's your traditional slope-intercept form for any line equation. You typically want to write it this way because that helps you plot the intercept and plot the slope easily. So we do know that m represents the slope and b represents the y-intercept. Now, I want to show you also this formula. This one is not as popular as this one here to use, but let me just say this is actually more popular for upperclassmen. So once you've kind of passed on Algebra 2, this is usually the more favorable formula to use. And I'll tell you why once we work it out. I'll show you the pros and cons of both of them so that way you guys can choose which one you are more preferable with. But this is actually my favorite. So to use this one, you will need a point because in this case, you would need to have been given some x value and a y value, so a coordinate point. And you need to be given a slope. If you're given those 2 things, you can easily use this formula to get back to this equation. So using this one to help us out, notice how it gives us a x value. I'll call this x1, and this one is y1, right? It also gives us a slope, so it gives us a point and a slope. And so how about, this is what I'll do. I'll divide this in half. See if I can shrink that down just a little bit. I don't know how much space I need. Maybe that much. And then I'll do the slope-intercept form here where I just use the slope-intercept form equation. And then the other one, I will use the point slope form equation. And I just want to mention, it's based off their names, right? The slope and the intercept is in this name because you can just plug in the slope and the y-intercept easily and then get your equation. Whereas this one works really great if you have a point and you're given a slope and you can figure out the equation from there. So in this one here, what we have to do is try to get this formatting. We need the slope and we need the y-intercept. Lucky for us, we know what the slope is, so I know what m is. Unfortunately, they didn't give me a y-intercept, right? So I have to figure out or solve for b. But the nice part is that I do have an x, I do have a y, so I can plug in y, I can plug in x, I can plug in m to solve for b. So what that's going to look like is, let's see here. So my y here is 2 equals my slope, which is 1/2, times my x, which is -4, plus b. So if I were to work this out, maybe I'll multiply this half with negative 4. So you can, turn this into a fraction and then multiply, or if you just think about it, half of negative 4 is negative 2. So that's a quick way you can solve. And then from there, you want to solve for b. So I have to add 2 to both sides. So that one would cancel. And so b is equal to 4. And here's the thing. Some beginners will forget that that this is not the answer. This is part of the answer because we were looking for b and we already had m. So we're going to plug in m and we're going to plug in our y-intercept so that way we can write our equation. So our equation is actually y equals 1/2 x plus our y-intercept, which was 4 that we found. And then ta-da, I have my equation. So the pro with slope-intercept form is when you use it, you can easily solve for b. So the equation is very short. It's easy for people to remember. And so getting to b it doesn't take you terribly long. The con to is that people sometimes will forget that this is not the answer, that they need to plug everything back into the equation. So it's like a two-step process if you use this type of way. Whereas this one here, you can see I'll work this out and I basically solve it in one go. So here's the formula for point slope form. So you want to use this formula when you have a slope and you have a point, basically. And so I'm going to plug in my y1 and x1. These are basically the same values that I am using from this coordinate. But I like to mention that your y and your x's are just variables. They're just going to be variables in your equation. So you're just going to, bring them down, move them around if needed. So y just comes down. y1 is 2. M here is 1/2. X1 is negative 4. So it looks like I have 2 negative sign. So now I'm just going to clean things up maybe on the right-hand side first. So those will become positive signs. And then it looks like I'm distributing a 1/2. So this is going to be 1/2 x plus 1/2 times 4. That's going to be half of 4 is 2. Or you could just, work this out by hand, make this 4 into a over 1, then multiply straight across, and then divide by 2. That's going to be a 2. So you get the same answer if you just work this out by hand as well. I'm going to bring down the y and the minus 2. And then notice how I'm very close to getting it in slope-intercept form. All I have to do is basically get this y by itself. To do that, I just have to move this 2 over. So I have to add 2 to both sides. So that means that y equals 1/2 x plus 4. Well, would you look at that? That is the same answer as I got last time. But I had to just do fewer steps to get there. Because with this formula, all I have to do is plug things in the first time. Yes, it's a little bit longer in the formula. But you can see here, I don't have to worry about replugging in things. I get straight to the actual equation. So, like I said, this one here, I prefer a little bit more, so I'm going to use it this way. But if you prefer it the other way, feel free to do it the other way. So let's try out one more example problem of where we have to find the equation and then put it in slope-intercept form. So I'm going to use that point slope formula that we just learned. So the point slope formula is that y1 minus, y minus y1 equals m x minus x1. This formula, if you like to use it for the test, which I recommend, I highly recommend that you remember the formula because the formula won't be given to you on the test. This is something you'll just need to know. So in this case, this would be y minus y1, which this would be my x. This is my y1, so this will be 3 minus m, which is 5 over 4. And then x minus negative 2. So again, this ends up becoming a positive sign, and then I have to distribute a 5 over 4. So this becomes 5 over 4x plus, let's see, 5 over 4 times 2 is going to be 10 over 4, right? So 5 times 2 is 10, 4 times 1 is 4, which can be reduced to 5 over 2. So that's going to be 5 over 2 over here. And then this side's y minus 3. So then to get y by itself, I have to add 3 to both sides. So then that cancels, y drops down, 5 over 4x drops down. I do need to add this bit. So you could change this to a decimal if you want and then add it with 3, or I'm just going to work out the fraction. I'd have to put this over 1, multiply top and bottom by 2 to make it the same denominator. So then I would have 5, 2 plus 6 over 2. And so then I can add the top together since it's the same denominator. So 5 plus 6 is 11 over 2. 5 over 4x equals y. Or like I said, if you changed everything to decimals, that's fine too. Generally, the thing you don't want to change to decimals is your slope. If you change your slope to a decimal, it's really hard to graph. But in this case, the y-intercept, if you want to change it to a decimal, that's totally fine. All right, so in the next slide here, I'm going to show you how you can write an equation. Like how do you write an equation given some conditions, but then how do you change it into a standard form? So here, remember that standard form is basically you have a line equation. So there's x's and y's, but they're all on one side. And a, b, and c are all coefficients or constants. But here's the thing. So I'll make this a little note here. A, b, and c are all whole numbers, or they're all integers. But that just means that they're whole numbers. Okay? So in that case, they can't be fractions, is what I'm saying. So with the first one here, we're just trying to get this as a equation of a line. So before I do that, I just want to mention, let's first, try to get just a line equation. So first thing you could do is just try to get it as, y equals mx plus b, and then change it into standard form. So that's usually what I do first. So again, this is your x1 and that's your y1, and so this is your slope. So if I was using that formula that we did before, the point slope formula, all I would do is plug in my y1, which is 8, my slope, which is in this case -2, and x here happens to be 5. So it looks like this time I'm distributing a -2 to the right side. So that's -2x plus 10. And so then the left-hand side, I'm just going to drop down, and it looks like I have to add 8 to both sides. That cancels. Y drops down, -2x drops down, and 10 plus 8 gives me 18. And so this here is slope-intercept form, but they want standard form in these two problems. So if you want to write it in standard form, well, that means the x's and y's all need to be on one side, or particularly the left-hand side. So I have to move basically this -2x to the other side. And to do that, we basically add 2x, right? So we would add 2x to both sides. This would be y plus 2x equals 18. And then you have your equation. And now it's in standard form. So this would be considered standard form. And so notice that with this, all the coefficients in front of x and y are whole numbers. That's a 1, that's a 2, that's an 18. Now this one here, let's see if we can work this out and get into standard form. So very similar to that last one here. So I have my x and my y, so I'm just going to plug it into the formula. So this time I'm just going to plug it straight in. So y minus 4 equals my slope, which is -3 over 4. X minus my my x value, which is -2. So then this becomes a positive, and then I'm distributing this fraction. So it might get a little bit messy with this fraction, but let's just hang in there. So -3 over 4 times x minus, let's see, let me do this on the side here. So this would be like -3 over 4 times 2 over 1. So that would give me -6 over 4, which reduces down to -3 over 2. So this is going to be negative 3 over 2 as my equation, or my number that's the constant. I'm going to bring down y minus 4. And so now I'm going to add 4 to both sides. So that cancels. So y comes down negative 3 over 4x minus, okay, so now I have to think about adding that negative 3 halves plus 4. So if you want to keep everything in fractions, you can, or you could just change this to a decimal as well. That'd probably be the easiest, but I'll show you guys how you could do it with fractions. So if I want to add this 4 to the 3 over 2, I have to put 4 over 1 and then change the denominator. So I'd multiply the top and bottom by 2. Negative 3 over 4x drops down, minus 3 over 2 plus 8 times 2. And so in this case, y drops down, negative 3 over 4x minus, well, actually not minus. So this one's negative 3 plus 8, so that makes 5 over 2. And then from there, oh, actually, take it back. So with this one here, do not change it to a decimal number because then you'll have a hard time changing it into standard form. So if it asks you to change it to standard form, do not change things into decimals. You want to keep them as fractions because you'll see here in the next step. So notice how I have kept everything in fractions. Okay, before I worry about the fractions, let me try to scoot the x over to the other side so I can get it into all the x's and y's onto one side. So I'm going to do that first. Can I squeeze this? Yep. So I'm going to add 3 over 4x to both sides. So that cancels. And so now you have y plus 3 over 4x equals 5 over 2. So notice how like this is in standard form, but the numbers in front of the variable, well, they're not all whole numbers, right? You have a 1 in front of y, which is a whole number, but then you have a fraction and then another fraction. So we have to change these back into whole number. And the way you do it is to look in the denominator. Whoever's the biggest denominator, you're going to multiply by that denominator. So this one's a 4, right, which is the biggest. So I'm going to multiply by 4 so I can cancel out that 4 in the denominator. So what I'm going to do is multiply everything by 4, because if I do something to one, I have to do it to all of them. So then this would be now a 4y plus a 3x, because that 4 will cancel out the 4 in the bottom. And then 4 times 5 divided by 2. So if you multiply 4 times 5 over 2, right, this would be 20 over 2, which is 10. So now this is just a 10. And notice now everything is a whole number. This is a 4, 3, and 10. And so this is my final answer in standard form. So this one is a little bit more difficult. This would definitely be more of a level 4 problem, looking at how much work there's been done. Okay, so one more slide. I want to go over one short story problem with you guys and see how that relates to line equations. So in this one here, it says that there is a $30 fee to rent a chainsaw. So I might want to highlight that. That could be important. So a $30 fee to rent, and then $6 per day. So I guess, you know, you buy this chainsaw to rent it. The first fee is like $30, and then every day after you're going to be paying $6 for each day you have it. Then it says, let X represent the number of days the saw is rented, and Y represent the charge to the user in dollars. If the total charge is 138, how many days is the saw rented? So first off, let's just kind of gather our thoughts for a bit. I think the easiest way to approach this is to see if you can make an equation first from the story. So that way you can use the equation to solve out whatever you need. So a typical equation is that slope-intercept form. So this is your line equation. And so in this case, when it says $30 fee, that's a one-time fee, right? So since it's a one-time fee, this is probably our going to be our y-intercept or our b value, because you only have to add it onto your total cost one time. And then $6 per day, well, that sounds like a slope, right? So because every day that passes, you have to multiply that by the day of the cost to have it, so $6. So in this case, if I were to write an equation in respect of that, this would look like y equals 6x plus 30, where x represents days and y represents, well, basically total dollars, right? So in this case, what it's asking is basically the user had to pay a total of $130. So this 130 actually represents the y value, the total cost. And it wants to know how many days you rented the saw, or x. So in this case, if I were to plug everything in, I know that, the total cost that I spent was $138. $6 times x, which I don't know, I have to solve. And so I'm solving for this equation. So I just have to do is, get x by itself. So I would subtract 30. That would cancel. 6x drops down. 138 minus 30 is 108. And then if I divide by 6, x is equal to 18, I believe. Let me just double check. So in this case, it looks like it was rented out for 18 days. So I'll just write that as the final answer. All right, and that's it. So a lot of these story problems will basically give you some information. You're going to try to develop a line equation or linear equation from that and use that to solve what it's asking you to find. So we'll practice this a little bit more. Maybe every day I'll give you a story problem to try to solve out.